Okay, so starting off with the introduction to chemistry. Do we use chemistry?
Yes.
Okay. Do you use it every day?
No. Yes.
Okay. So let's consider. Okay, when you wake up in the morning, right? What are the first things that you do?
Look at your phone. Brush your teeth.
Okay. Oh, okay. Sorry. Besides looking at your phone, seeing what kind of messages you have, hopefully you're going to
Brush your teeth.
brush your teeth. Okay. So is there chemistry there?
Yay.
Okay. What's one of the main things that we normally look for in toothpaste? That it has what? Fluoride, right? Fluoride, though, you have to be careful. On the periodic table, it's fluorine. Fluorine is dangerous when it's pure fluorine, right? It can kill you. Fluoride is when fluorine has become ions, and that's what we actually need to keep our teeth healthy. Okay, so there's a difference between the pure element and when it's in its ionic form. For example, we talked about this. What do we put in our food? Salt. What is salt?
Sodium chloride.
Okay, NaCl, sodium chloride. Again, chlorine, different from chloride, right? Chlorine, it's in its elemental state. It's a green gas that if you inhale it, it will kill you. Okay? Sodium, in its elemental state, is a silvery metal that reacts with water. It can actually explode with water. So you can imagine if you put sodium in your mouth, there's plenty of water there, they would actually explode. But does sodium chloride do that?
No.
No, because it has different properties. It went through a chemical change to go from its elemental form to its ionic form. Okay? Yes, sir?
What is the popping candy?
Okay, so what happens in popping candy is when they make the candy, it's actually made to where it actually absorbs carbon dioxide in it. Right? So it actually has carbon dioxide trapped inside the candy. So when you put it on your mouth, right, it starts dissolving, and when it starts dissolving, what happens to the carbon dioxide? It releases it, and that's what causes that popping. All right. So sodium chloride, right, is good for us, right? Our body actually needs sodium, right? Now, I try to bring in some biology, but the last time I took biology was 1984. So it's been a few years, right? So since you just took it last year, you should know more than me. All right, so the reason we need sodium is our heart, right, beats at a certain rhythm, and it actually uses what's called the sodium-potassium pump. It's sodium ions and potassium ions going back and forth in your body. Right, so sodium, we're going to get that from salt. Where do we get potassium from? Bananas, right? So that's why they always say bananas are good for you, because our body actually needs it. Okay, so again, that's something we use pretty much every day, sodium chloride chemistry. Now, has anybody looked at the container for salt? What does it say besides salt?
Sea salt.
Okay, it could say sea salt. Okay, iodized salt. Okay, so that's another thing. Iodine by itself actually kills things, right? Small amounts of iodine, I don't know if you've ever had a cut that they put a brownish liquid on. Okay, that one has iodine, but it's like 0.04%. It's an extremely small amount. It's enough to, it won't damage you, but it'll kill off bacteria and other things, right? But now again, that's pure iodine. Iodide, IDE at the end, it's the ionic form, and again, our body needs it. Now, again, I don't know how much you remember from biology, but we have a gland here. Anybody know what gland we have in our throat?
Thyroid.
Thyroid gland. Okay, the thyroid gland actually requires the what? Okay, so when there's damage to it, then that's when you can get thyroid cancer. That's one of the diseases. The other one is like hyperthyroidism if it's working too fast, hypothyroidism when it's working too slow. But there's a fourth thing that happens. If you don't get enough iodine, it actually starts to swell and inflame, and you get something called goiter, right? Your neck gets really inflamed, and you basically can't swallow through anymore because it's so large. So that's why, since there is no common way of getting iodine, they put it in our salt so we don't have to worry about it. Okay? All right, so in the morning we brush our teeth. What's next?
You wash your face, take a shower.
Okay, wash, ready, take a shower. So hopefully you're using soap somewhere along the line. So soap actually contains a base, right? Soap has a base, so that way when you rub it on your skin, that base is the one that's breaking down all the oils that are on your skin. So that way all that stuff will come off, right? So if you just shower with just water, none of that stuff's going to break down, right? So it all stays stuck to your skin. You need a base to actually break that down. Okay, then hopefully at some point you're going to use shampoo. At the end, after you're done, you'll put some deodorant on. If not, it's always a good idea, right? A lot of deodorants actually contain aluminum in them, right? So if your clothes start getting white stains across there, a lot of times that's the aluminum compound that's causing that stain. Okay, so that's why some people are getting away from deodorants that contain aluminum compounds. All right, how do you get to school?
My mom drives me.
Okay, your mom drives you, you come in a bus, right? Does that require chemistry? Gasoline, right? So what happens to the gasoline?
It burns.
It burns, right? And during that burning process is providing energy to move the vehicle, either your mom's car or dad's car or the bus itself, right? What about the clothes that you're wearing? Does that require chemistry? Okay. Well, obviously you have to wash it. That'd be a good thing, right? What about the color? What causes the color in your clothing? Okay, dye, pigments. Again, that's all chemistry. Why does a shirt look black?
Because it absorbs the color.
Okay, it absorbs all the colors from light. Okay, why does that jacket look blue?
Because it absorbs every color except for
It absorbs all the colors and it only reflects blue. So that way when you're looking at it, your eyes are picking up that blue light coming off of it. Right? One of the things that we'll discuss later, one of the things that we'll discuss later are what are all the different colors in visible light? Red,
orange, yellow,
orange, yellow.
green, blue, indigo, violet.
You missed a couple. So we have a mnemonic that we try to remember. Roy G. Biv. Right? Red, orange, yellow, green, blue, indigo, violet. Right? So again, the pigments, right, the dyes in clothing interact with those colors coming from visible light. Right? So we're always using chemistry. Right? So that's why I like chemistry so much. All right, so chemistry, the study of the composition. So what do we mean by composition?
How it's made.
What it's composed of, what it's made up of, right? So what normally are we looking at in chemistry when we talk about what something is composed of? The elements, right? And what is the smallest part of an element that we can have? The atoms, right? So if we're going to go all the way down to the basic form, we're looking at the individual atoms that are there. Now, if it's two atoms joined together, what do they form then? Molecule, right? So we would have molecules in that case, right? And once we start dealing with molecules, we've got compounds. Okay? So that's what we have with composition. Okay? And the changes those substances undergo. What kind of changes can we have?
Chemical.
Physical and chemical changes, just like we saw yesterday. Right? So that's what we have for chemistry. Those are the main things we're interested in. What is it composed of and how does it behave? All right, so where do we find chemistry? No, it's still working. All right, how do we use it in agriculture?
With the sprays.
Okay, right. So crop dusters, they're spraying pesticides, right? So that would be the bad way because they're getting rid of bugs and so on. And then how do we help the plants themselves with what? Fertilizer, right? So we've got fertilizer, right, which provides chemicals, right, to the plant itself. Pesticides, which the chemicals that are there are to prevent creatures and so on. Mulch, not exactly chemistry. That one, what they're trying to do is they're trying to prevent other things from coming at it, right, or to provide heat for the plants themselves. Okay. What about medicine? Where do we find chemistry in medicine?
With like all the acids like they put in there.
Right. Everything in medicine is chemicals, right? How they make the stuff and so on, right? So, the what? Right. Exactly. The interesting thing is, how does it know where to go in your body, right, when we take a medicine? Okay. And that's the thing. Certain chemicals in our body, right, will attract the chemicals in the medicine itself.
I've always wanted to like see through like a little camera like what happens.
And they actually have that these days, right?
It's always
Pretty weird.
There's small pills that actually have cameras in there because when people are having problems in their esophagus, they'll actually swallow that and it actually takes pictures as it goes down.
And then you just get it when
Next thing, manufacturing industries. Simple example is the desk that you're on, right? Did that require chemistry? Right? The metal that's on there, more than likely it's an alloy. And what do we mean by alloy?
Like two different metals.
Put
Right.
another metal.
Combination of metals, right, put together. Right, what about the top of the desk? Did that require, is it really wood?
No.
Right.
It's not
Right.
even wood.
So it's something, right? So that's the thing. It's like a polymer based going around there or something, trying to protect it. So, not exactly granite on that one. All right. So pretty much anything you see around you has chemistry in it. So what we do though is we try to separate on what type of chemistry it's going to be. So we actually have 6 types of chemistries that we're going to discuss. Since chemistry is so diverse, it is usually considered to have the following 6 major divisions. Anybody know what one of the divisions for chemistry might be? Very good. Yep. So biochemistry is one of them, right? And what does biochemistry deal with? Chemistry of, not necessarily just of our body, but of life, of living objects, right? Living things. Okay, so let's try to see what the other ones are going to be. Okay? And again, this is the way we separate any of the substances that we encounter. We're going to put in one of these 6. First type is organic chemistry. First one, organic chemistry, the study of essentially all substances containing carbon. As long as a substance contains carbon, we would classify it under organic chemistry. So that little picture that you see there is an example of benzene, which is a hydrocarbon. So what kind of elements do you think benzene is composed of? Hydrogen and carbon, right? So that's all a hydrocarbon is, just a substance made out of hydrogen and carbon atoms. Okay, so what do you think the opposite of organic chemistry is going to be?
Unorganic.
Not un, right? There is inorganic. Very good. Inorganic chemistry, right? So what do you think inorganic chemistry is going to be about?
Some stuff about nothing with carbon.
Right. Substances without carbon. So inorganic chemistry, the study of substances without carbon. So for example, salt. Which would salt fall under? Inorganic. Because what is it composed of? Sodium and chlorine. No carbon there. So it would fall under inorganic chemistry. All right. Next one. Analytical chemistry. What do you think we're going to do with analytical chemistry? Analyze it. And what do we do when we analyze it? What do we figure out?
What is composed?
Exactly what it's composed of. Okay, so analytical chemistry used to determine composition of substances. Again, it's going to go through some type of analysis. So if you've seen, for example, CSI, right? They normally put a substance into this box-like thing. It'll analyze it, right? It gives it to them like in 3 minutes. That's not the way it works. It takes a lot more than just 3 minutes, right? But they're basically using analytical chemistry to determine what the composition of a certain substance is going to be. All right. The next one you did yesterday in your experiment. You did physical chemistry. All right, so again, this is what you did yesterday, physical chemistry, because you were able to see the properties of the paper, right? Both the physical properties and the chemical properties. Again, some of the physical properties of the paper were that it was smooth, it was white, right? That you could fold it, crumple it up, and so on, right? What was a chemical property? What did the paper react with when it burned? Oxygen, right? That's one of the chemical properties. It reacts with oxygen. Now, what kind of changes did we put the paper through?
Color.
Okay. Okay, went through physical changes. That's when we were folding it, crumpling it up. And then it went through chemical changes, and that's what the one you said. It changed color, right? When it was burning, right? It was turning from one substance to the other one, right? But you'll notice at the very end, we needed some type of energy for any of those. If you were folding it or crumpling it up, you had to use energy to do that physical change, right? To start the chemical change, we had to apply a flame to it. We had to apply heat for it to start burning. Okay, so all those are part of physical chemistry. All right, the next one is the one that you had previously said, right? The biochemistry. Oh, I forgot the little animation there for your analytical chemistry. All right. So biochemistry, right? DNA molecule deals with something from a life form, right? So we've got biochemistry. Okay, so biochemistry, the study of composition and changes in composition of living organisms. Again, composition, DNA molecule. What elements do we have in the DNA molecule?
Oh.
DNA?
Phosphorus.
Magnesium.
Okay, but that's a molecule. What is that molecule composed of, right? So normally what we find in living organisms, carbon, oxygen, hydrogen, right? Nitrogen, phosphorus, right? So there's a lot of different elements, right? They come together for biochemistry, right? And again, it's the composition, the different elements that we're composed of, but also the different reactions that take place, right? For example, when you're going to eat something, what's the first type of reaction that happens in your mouth?
Chemistry.
Okay, but what kind?
Physical.
Okay, well, you have physical when you're chewing it, but is there chemical reactions going on? Okay, what's in the saliva? Enzyme, right? Not acid yet, right? So we've got enzymes that we add to it. Now, as it goes down the esophagus to your stomach, then that's when we encounter acid, right? So there's another biochemical reaction that's taking place, right? So we're talking about not just the composition of the living organism, but the actual chemical reactions that take place in there. Okay, so that's our biochemistry. Okay, and the final one, I apologize, it's kind of long, right? But because of the information that it has in it. The use of mathematics and computers to understand the principles behind observed chemical behavior and to design and predict the properties of new compounds. Okay, so in this case, and the little animation that's on the bottom is where are the electrons currently located? What's the idea where the electrons are located right now? Okay, it used to be in energy levels, but now it's the cloud, right? It's a probability cloud. So probability deals with mathematics. Where do they think that electron is going to be found? But now, once we start forming molecules, those electron clouds start joining together. So what do those look like? So they use mathematics, and this is what they come up with on those animations. That's the kind of structures that they think the electron clouds take on. And again, these are probability clouds, where are we probably going to find the electrons. So depending on the atoms that are coming together, we can have any of those three types of shapes for the electron clouds, for the probability clouds. Okay? So that's what we're using the theoretical chemistry for. Try to figure out how, right, or what makes the behavior the way it is. And finally, if they're going to design a new type of substance, how might it react? What kind of properties are going to be there? So that's what we use theoretical chemistry for. Now again, we separate them into 6, but these all work together. For example, if we find a brand new substance, what kind of chemistry are we going to use to try to figure out what it's composed of? Analytical chemistry, right? Because we're going to analyze the substance. Once we figure out that it contains carbon, what kind of chemistry are we in now? Organic chemistry, right? We've got organic chemistry. If we're trying to look at what kind of properties it has, what kind of chemistry are we dealing with then? Physical chemistry, right? And then what scientists normally do, let's try to feed it to these mice and see what happens. What kind of chemistry are we dealing with there? Biochemistry. And finally, if we want to figure out why it behaves the way it does, we would use theoretical chemistry.
Are we done, sir?
No. All right. So are we okay with this? So those are the 6 types of chemistry and how they go together. Now, when we're dealing with chemistry, right, we're looking at research. What kind of research can we have? And we actually have 3 types of research. And this will be it for today, dealing with these type of research. The first one is just when we're trying to gain knowledge about something. So that's called just basic research. So basic research carried out for the sake of increasing knowledge, right? Something happens, they're trying to repeat the experiment to see if they can repeat it and why that happens. The next one is when we actually use that knowledge for something. That's referred to as applied research. All right, so applied research generally carried out to solve a problem. Now that you have the knowledge from basic research, you can apply it to solve a problem. And one of the best examples is mold. What does mold make?
Mold makes mold. Mold makes mold.
What's that bacteria?
Well, it doesn't, it actually kills off bacteria because mold creates penicillin. Okay? Again, you should have seen this. Should have seen this in biology, right? This is the best example for these 2 things. Right? Somebody noticed that around the mold, on the outskirts of the mold, no bacteria could live there. So they figured out that the mold was actually creating some substance, some chemical that killed off bacteria. So scientists were able to actually isolate that using their basic research and finally apply it to actually kill off bacteria, right? So that's how they made penicillin. they were able to make that substance that killed off bacteria. Okay? So that's your basic research and applied research. These days, though, we've taken it one step further. Okay? What does pretty much everyone carry these days? A smartphone, right? That's what we call technological development. Instead of solving a problem, we're just trying to make things easy for ourselves, right? We don't want to carry around a computer. We don't want to carry around something that holds all our music. We have it all in one place. So that's our technological development. All right, so we'll continue with that tomorrow. You're dismissed. Have a good day.